All right, this is page 61 in the NuLake book. I'm going to do the part that is the mixed problem part for the algebra. So here we go. 4 years ago, John was half the age he will be in 10 years' time. Form an equation and solve it to find John's age now. Okay, cool. I'm going to call that x, John's age now. Okay, 4 years ago, John's age. 4 years ago is what? X minus 4, isn't it? Was half the age he will be in 10 years' time. 10 years, 4 years ago, that's that. Half the age he will be in 10 years' time is, his age in 10 years' time is this, x plus 10. Cool. So if it's half the age he was, cool. I'm saying that you can say this in two different ways. I can say that I'm just going to get rid of this because it's confusing. I could say that, but I could also move that half away and say that. So twice the age he was 4 years ago is the same as his age in 10 years. So either way, make that equation. So I've done the form and equation part. I'm going to make my pen a bit thinner. And then let's find John's age now. So John's age now is x. So we're just trying to find x at this point. So expand. Okay. Let's put it all together. I'm just going to move it all to the left. So I'm going to minus by an x both sides. So that 2x becomes 1x and that's gone. And I'm going to move the 4. I'm going to add 4 to both sides. So that becomes, instead of a 10, becomes a 14. His age, or he is 14 years old. Next one. The sum of the squares of two consecutive whole numbers is 145. Form an equation and solve it to find the two consecutive numbers. Okay, two consecutive whole numbers, right? So let's say the two numbers are, I don't know, like A and B, right? But instead of writing A and B, because we know they're consecutive, let's not use two different variables. We might as well just choose one. So we'll say A is the first of the two numbers. And then the second number, we're going to call it A plus 1 because it's consecutive. It's the next whole number, right? So this is better for us because it only has one variable for us to work with, and we're more likely to get a nice equation that we can actually solve. Sweet, let's go. The two consecutive numbers, the sum of the squares. The sum of the squares is this. That's a square. That's a square of the second number, but the sum of those two squares is, when you add them together, is 145. Cool. Form an equation and solve it to find the two consecutive numbers we just have. Let's find the two consecutive numbers. Okay, here we go. Which means find A for us. If we find A, if A is, I don't know, 5, then we know it's 5 and 6. If A is 20, we know it's 20 and 21. So let's find out. Let's just expand. Remember, when you expand this thing, we don't just go A squared plus 1 squared. It's this business. Don't forget that, right? So it's A times A times 1, 1 times A, 1 times 1. So we end up getting A squared plus, we get an A and then plus another A. So I'm just going to say 2A plus 1 equals 145. Okay, we seem to be getting a quadratic. So I'm going to move it, if it's a quadratic, I'm going to move it all to one side and make one side have everything and the other side equal 0. So Let's do that. That's 2a squared plus 2a. And then I'm going to move the 145 over to the left. I'm going to minus 145 from both sides, which makes that 0 on the right-hand side there. And it makes it plus, no, not plus, a minus 144. Cool. I immediately see a common factor here. I could say, instead of 2 plus 2 plus minus 144, I can say that bring that 2 up there, and that would be 72, right? Yeah. Yeah, so I've divided everything by 2. I can say that's a common factor. I can divide both sides by 2, but so that 2 is gone, divide that by 2, and 0 divided by 2 is just 0. So there we have it. That's an easier equation for us, isn't it? And let's solve it. Let's factorize it. So remember, when we're solving a quadratic, generally we factorize it. So I'm looking for two numbers that add up to 1, but multiply to a negative 72. So if it multiplies to a negative number, we know that 1's a positive number and 1's a negative number, right? Cool. So I'm thinking a number that adds to multiplies to 72. I'm thinking 9 and 8. 9 and 8 is great because it also is a difference of 1. So if I say plus 9 and then negative 8, that's a bad 9 because it looks like the A. Yep, if I add them together, I get a plus 1. And then multiply, I get negative 72. So cool. So we're saying A is either negative 9 or A is 8. So I think we have two possible consecutive numbers here. So which means the two numbers are either 8 and 9, or also it's negative 9, and then the consecutive number after that is a negative 8. They both seem to work. Do they say anything about being a positive number? No, not really. Doesn't say. So yeah, we have both these combinations. If it is a case where there are two possible answers, you should give both answers. So remember, these two are not the answers we're looking for, as in it's not negative 9 and 8. They're not consecutive numbers. Okay, cool. Remember, A was the first number of the two consecutives, so we have those two possibilities. Sweet. 483. Study the diagram of the wedge shape below. Give an expression, so that's just an equation, an expression itself, for the area of the base of the wedge. That one there. I assume it's the same as that, because it's a wedge. Cool. Which is the area of a triangle is the half times, or base, or width, or whatever it is, times height, which is, in this case, it's just that one and that one, not the 5x. So our equation becomes half times 3x times 4x, which I'll expand and I'll simplify it. It becomes 6x. Cool. There it is. That's the expression for the area. If the surface area of the wedge is that, give an expression for y. So we want a y equals something or other. In terms of x, so we're going to have x's in there, and we're going to be happy with that. Sweet. But that's what we want. But let's make an equation first with the information we know. Surface area, I'm going to put a little small a there. Surface area is, well, before we say 3,600, is the sum of all these areas. So we know it's 6x. 6x is from before, that's the base, but we know we have two of them. We also need this square, rectangle, sorry, which is, so we're going to add it. We're going to add 3x times, that's a y, isn't it? That length there, times y, so 3xy. And I need, get rid of that. I need that rectangle there, which is plus 5x times y, so 5xy. And lastly, I need that one, which is 4xy. Cool. So that's everything. 1, 2, 3. Yeah, that's everything. And we also know that surface area is 3,600. And I'm just gonna simplify this whole line because we can add them together, can't we? So that's a 12x plus 3 plus 5 plus 4. It's 12xy. Cool. Now remember, we want to make an equation that's y equals something. We want to make an expression for y. So we want to isolate. We want to leave everything out except for the y. So let's just move everything along. I'm going to say 3600. Oopsie daisy. 3600 minus 12x equals 12xy. Right? I've moved this fella along by doing that. Oh, and I can also see that I can divide it all by 12. Let's do that. Let's get rid of the 12. Let's divide both sides by 12. I get 300. Yep. 300 minus x minus just xy. That's easier. Okay. Remember, simplifying it and giving it in its simplest form is also a part of the answer. It's normally a given. Anytime they ask you for an expression or anything, it's a given that you do simplify it. Anyway, to get rid of that x there from that y, to separate it, I divide both sides by x. So I know it's 300 equals y. I can flip that around. But before I do, I'll write the final equation here. But before I do, remember this is the same as, oopsie daisy, what have I done? That is the same as this is the same thing. It's just written in different ways. So, and we like using this because that one simplifies as well. So we say y equals 300 over x, sure, minus 1. And there we have it. That's our equation for y in terms of x. And in the simplest way that I can think of right now. Moving on. 484. A, if you select two consecutive odd numbers and multiply them together, and then subtract twice the smaller number, what do you always end up with? Okay, let's think about that. Let's think of two consecutive odd numbers. Let's stay in the positives. Like 1 and 3 is 1. So if I multiply them together, so like 1 times 3, and then subtract twice the smaller number. So 2 times 1, right? So there and there, yeah. So double that. What do I get? So that's what, 3 minus 2. 3 minus 2, I get 1. Okay. Let's try some other numbers. Let's try 3 and 5. Actually, I should have tried this on the side. Let's try it on the side. 3 times 5 minus 2 times 5. I get, that's 15, that's 10. I get 5. Okay. I don't know what I'm supposed to get. Let's try some more. Oh, wait, no, of course. Wait, why did I do that? It's by the smaller number, isn't it? So it's not 10. It's 15 minus, what is that? 6. So that's a 9. Okay. So I've started seeing something, but let's do one more just to clarify. Let's try 5 and 7. So 5 times 7 minus 2 times 5. What do I get? So we're just trying a few. We're just experimenting at this point just to discover this. Because I guess that's just, this question's really vague about it. So, and plus the next question seems to be proof. So I'm not going to algebraically prove it yet. This one, 5 times 17 is 35 minus 10, I get 25. Okay, so I've noticed something, and I wonder if you have as well. That first one is actually the weirdest one. It's hardest to notice. But that answer there with our two numbers, 5 and 7, any relationship? Have a think. Think about that answer 9 that we got from 3 and 5. Any relationships? Because they've said there's a relationship, we know we're looking for one. So what you get is you always get the square of the smaller number. It's what we always get. Well, it seems to be the case, isn't it? That is 5 squared for 5 and 7. For 3 and 5, that is 3 squared. For 1 and 3, that is 1 squared. So we seem to always get the square of the smaller number. This is actually, if you want to be real tedious about it, it's not really a proof. A proof, we will have to use some algebra. So to prove that it works for every possible odd number, and there are no exceptions. If there are exceptions, then we would have to try numbers, for an uncertain amount of time. So which is why we use algebra in general too. Anyway, so let's try it. Now, when we algebraically, so pick an arbitrary odd number, we write it like this. So first of all, if I say two even numbers, if I say n even number, we say it's 2 times something, because an even number is a number that you can divide by 2. So some arbitrary, undefined even number, that's how we write it. Now, an odd number, this is how we write it. An arbitrary odd number, this is how we write it. It's that 2x for whatever x is, some whole number plus 1. And that's, we can practically, we can say any odd number using that expression. Now, if we say two consecutive odd numbers, we say 2x, so same x, whatever that x is, plus 3. Because 2 more after the first odd number is the next odd number. Cool. Moving on. That's how we have it. So what have we done? In our first one, we say we're multiplying the two odd numbers together, right? That this number and this number, multiply it, and then we're minusing twice the smaller odd number, that. Now let's see if it does come to be. We're hoping to get the square of this number, which is 2x minus squared. I mean, sure, it might not be factorized. It might actually be expanded, but we'll be ready for that when it comes. So 2 times 2x is 4x squared. 2x times 3 is 6x. 1 times 2x is 2x. 1 times 3 is 3. Minus 2 times 2x is 4x. 2 times 1 is, remember it's minus 1 because that's a minus. We're minusing this whole thing here. So if you forget about the negative sign, 2 times 2 is 4x. 2 times 1 is, sorry, not 1, 2. However, because we're minusing the whole thing, we're minusing both of these terms that we got out of it. Anyway, carrying on. That's equal sign here. Let's just clean it up. Let's bring the like terms together, which brings us to 1. Cool, there we have it. Yeah. Now, if I want to factorize this, I have to think of two numbers, like, I don't know, a square and a triangle. That's an A. Two numbers that add up to a positive 4. but also multiply to that times that, which is just a 4. So it needs to add up to 4. It needs to multiply to also a positive 4. Cool. I think about those two numbers. I'm thinking 2 and 2. A positive 2 and a positive 2. So we rewrite this equation like this. We just change that bit there. We split it up and say 2x plus 2x. Right? This is just quadratic factorization. Oops, forgot the square there. Yep, that's the step, and we factorize that, and we factorize that separately. And I know that's not a complete and perfect factorization, but we are okay with that at the moment. Now we take that, if we can take the common factor out of that, it's the 2x, and we get left in the brackets is a 2x plus 1. Okay, from that one, there's nothing to take out. There are no common factors, but it's just 2x plus 1. I'm going to put a bracket there. Because it's the same thing, really. It really is the same thing, but it just simplifies it for us. Okay, I'm gonna use this space just to finish up, just for space. Cool. Now that's a common term for us. That's a common factor. So we take that out. Equals plus 1. And the factors that remain is the 2x. And this, we're saying, I know there's no number there, but that is one of this bracket. That's one of that bracket. So it really is that. And as you can see, there we have it. It does indeed come to the square of the smaller number, no matter what odd number it is. Cool. Moving down this way. Give an expression for the shaded area in the diagram below. What am I doing? Okay, cool. Here's the diagram. Here, if you have to work with a shape like that and you have to work out the area, we do have to cut it up. And you can cut it up in many ways, right? You have to cut it. You can find out this whole thing and you can subtract. You can subtract those pieces if you can figure that out. You can separate it like that or something and work with that rectangle, that rectangle, that rectangle. Either way, whatever works. Remember, depending on the information we have, not all of these methods, it might not be the case that all of these methods work. So we might have to backtrack a bit. But you try one, you see if you have the right information, and you run with it. All right, so how shall I do it? I feel like this would work and that would work because this is what 2x plus 3 times. It'd be not exactly that. It'd be 2x plus 1 minus 1 and minus 1. So minus 2. So, oops. Something like that. And then I could work this out and I could work this out. I think I could. Yeah, I could. I could. Shall I do that? Let's do that. So I just need an expression. I don't even need to work it out. I just need an expression for this. It's 2x plus 3 times, bracket. The area is 2x minus 1, right? That's this thing here. Plus, now we are adding these areas up. So that square there, it is, I know, going to be, that's x and that's 2. So that's 1 times x plus 2. That's the x plus 2 is that length there. That is the 1. Cool. And this little thing there is a plus 1 times 2, which is just a 2. And this one is just an x plus 2. I don't need the times 1 really. Let's expand it and simplify. So these are pretty simple. This is the only work here that I'm gonna need to expand. So that 4x squared that is negative 2x. That is a 6x. That is a minus 3. And then plus x plus 2 plus 2. These are just left over from there. Cool. And then like terms together. Here we go. X squared, there are no like terms. X's, there are a few. Let's have a look. I think it's 5x, positive 5x. And then number-wise, let's go, and I'm going to say it's a plus 1. All right, cool. There it is. I mean, maybe we can factorize it, but they've not asked me to, so I'm not going to. There you go. Right. If the shaded area measures that, remember, this is B, so we are carrying on from the same one. Yep, so I wonder if you can hear that as well. The baby's crying. I wonder what's happening. Just a little upset, maybe. Anyway, if the shaded area is that, find the value of x. So we're saying, for this equation that we've made, we're saying the area is 27 centimeters squared. Yep. So let's just rewrite that, but I'm going to put 27 in place of the a. 4x squared plus 5x plus 1. Is that right? I hope I got that right too. Hope that wasn't a mistake. Right. So we've just substituted 27 into a. Right? So a equals 27. Right? All right. Let's move that around a bit. It's a quadratic, so I want to make it equal 0. So it's 4x squared plus 5x, and we have minus 27 from it, so we're going to get 26. Right. Okay, now to work with this, right? Just checking, make sure. Because if I got this part wrong, then all of this fails. But I'm just going to press on. Let's factorize this. So I want two numbers that add up to 5. That's a bad 5. Add up to 5. But multiply to 4 times negative 26, which is 104. Right? I'm feeling very unconfident about my yeah, 104. Remember, you can definitely take your time doing this. Sweet, there we go. A negative 104. So I want two numbers that multiply to a negative 104. Cool. I'm thinking 8 and 13. That's a difference of 5. I'm assuming, one of them's negative. Like that one's probably negative. That's a negative 8. We'll work on that later. We'll just do the multiplication. That's a 24. There we go. Plus 80, which is 104. There we go. And we know that 8's the negative number because we know it adds to 5. So we need the bigger number to be positive. So we rewrite it like this. Now we have something to think about. Do I put the 8 first or the 13 first? We think about the factors. We have to factorize that and the 8 together, or that and the 13 together. And thinking about that factor, and think about this one. I have to factorize this along with either an 8 or a 13. Think about which one works better. And you'll see that, 4 and the 8, they work nicer together. That's a negative 8. And then 13 and the 26 also, they work better together to be factorized. They have more common factors, right? It's more apparent. So factorizing that part gives me 4x taken out, factorized out, and I have an x in the inside, and I have remaining a minus 2. Yeah, because that would give me that. Okay, plus I can take out a whole 13. That's an ugly 13. There we go. Minus 2. there we have it. We have the two brackets that's the same. Perfect. Then we can factorize that out. Boom. So let's think about it. Let's solve it. So we're saying x minus 2 is 0, or 4x plus 13 is 0. So x is either 2, or x is, and I'm going to do two steps at the same time, 13 over and the 4 divided by 4. So that's a negative 13 over 4, which is the same as a negative 3 and a quarter. 3.25. But are they both the answer in our case? Having and looking at this diagram here, we know that x is going to be a physical value like that. So I don't think it'll be a negative number. All right, so x is positive, so x equals 2. Pow, we've solved for x. And I'm going to actually cut it here. I'll do the next page in, well, immediately the other video. I'll record a separate one. So that's the first page of mixed problems, page 61. Yeah. Is that a chicken? Anyway, yep, you try that yourself. Try this page yourself, then watch this, go through it, write it down, whatever it is that you, whatever question that you need. And then, without looking at it, try that question again, just you and a piece of paper. You do have to put that kind of work in, that repetition in, for it to be yours, for the knowledge to be yours, and for you to take out and use at your will, at your disposal, in a test time. So, do put that work in. But otherwise, see you in the next one.